Hello everyone. Today we will be solving a question on CPU scheduling that was asked in GATE 2012. In this question, we are given three processes P1, P2, P3, and we have to apply FCFS, that is first come first served, and round robin scheduling, for which the time quantum is 2 time units, right? And what we have to find out is what will be the completion order of the three processes according to FCFS and round robin. Without wasting more time, let's now do the numerical. So if we talk about this FCFS, so FCFS is very clear, right? So here I make the Gantt chart for this. And let's also make a concept, one more concept I want to explain you is ready queue. So here I am making the ready queue, right? So first process that is going to occupy this CPU, so Gantt chart basically represents your CPU, right? So at 0th millisecond, the process P1 arrived and it will take the CPU and it is going to run for next 5 milliseconds. So 0 to 5. Now, meanwhile, when at the first millisecond, the process P2 joined. P2 joined this, and so it did not get the chance to run into the CPU because P1 was already P2 has already occupied the CPU and it was running into this. So by the time what happened was your P1 just went to this ready queue and started waiting over here. After that, even after this third millisecond, who joined? P3 joined again, but P1 was running. P1 has to run for 5 milliseconds. So again, P3, sorry, here it will be P2. So then P3 also went to the ready queue and they started waiting. And you know very well, queue is based on what principle? FIFO. So the first process which was inserted will be deleted first. So once P1 will complete its execution, now this P2 will be deleted from your ready queue and it will take the CPU and it is going to run for next 7 milliseconds. So 5 plus 10 is 12. 5 plus 7 is 12. Then after that, again, this process will be deleted from the ready queue and this will occupy this CPU and 12, it is going to run for next 4 milliseconds. That is 12 plus 4 is 16. So it's very clear from here that in case of FCFS, what will be the order? The order will be first P1. P1 has completed its execution. As you can see, P1 completed its execution, then P2 and then P3. First P1 completed execution, then P2 and then P3. So now let's see the options. Let's go back to the question once again. As you can see here from option A, P1, P2, P3, this can be the correct answer, but this is not the correct answer because P3 has broken the series. Now C can also be the answer, P1, P2, P3. And what about D? D is again incorrect. So the answer can be from option A and option C. But now round robin is going to decide which one of them is correct. Now let's just mark what can be the different options. So options can be either A or it can be either C, right? Now let's start doing this question. So first I will make this ready queue. This is the ready queue. Because this question will be understood only with the help of the ready queue. And then also so this is your Gantt chart that we are going to draw. And this is for round robin. Time quantum here is 2. So the very first process that arrived into the system is P1. So P1 arrived at 0th millisecond and it is going to run for next 2 milliseconds because time quantum given here is 2, right? But what happened in between? At first millisecond, who arrived into the system? P2 arrived. But because P1 has to run for the first 2 milliseconds, so where P2 will go? So it will take the place in ready queue because ready queue is the queue where all the processes wait for their done to execute into the CPU. So now this P2 will go to the ready queue and it will wait here for its turn. right? Just after 2 milliseconds, what will happen? P2 will get active because now the turn is for P2. Now P2 is going, so this is P1 actually. So this is P1. Now P2 has to come here, but for that, this has to vacate the space, right? So this has to be emptied now. So it will be deleted from the CPU, and you can keep it here also, but for simpler reason, I will keep it here. So now P1 will take the place here, and then, so this will take the space here, and P2 will come here. So now P2 has taken the system, right? And again, P2 is going to run. So this is deleted, right? So this is now deleted. So P2 is going to run for next 2 milliseconds as the time quantum is 2. So 2 plus 4 is 2 plus 2 is 4. Even just, do the changes over here. So P1 run for 2 milliseconds. So the time left is 3. And P2 run for 2 milliseconds. So time here left is 5, right? After this, again, what happened is, as you can see, P3 arrived at third second. So this, at the third millisecond, who arrived? P3 arrived, right? But again, as P2 has to run for the next 2 milliseconds, so what will happen is, this is going to take the place in your ready queue. So it is waiting in this ready queue, right? So now it will be waiting here. But what is the principle of FIFO? Now, which process has to come next? This is the question. Which process will come next into this CPU? Who will take the CPU next? So as we can see that, because first of all, P2 is going to empty this, then only something else will come. So first this P2 will empty this place from the CPU, and P2 will now go back to the ready queue and will come after this. But then who is going to come next? As if I talk about FIFO, ready queue, queue is based on the principle of first in, first out. The process which was inserted first is going to be deleted first. So because P2 has already been deleted, now which process is going to be deleted next? This. So this is going to be deleted, and it has to be inserted here into the CPU. So now P1 has again taken the CPU, right? And it is going to run for next 2 milliseconds. So 4 plus 2 is 6. So how much time is left here? 1, right? So it has been now deleted. So let's delete it. It is no more there in the ready queue. Fine. So these two are waiting here. So after this, what will happen is, we have P2 and P3. Again, who is going to take the CPU? Next question is, who is going to take the CPU? So who is out of P2 and P3, who was inserted first? P3 was inserted first in this queue. So this is going to be deleted from here, and it is going to be inserted inside this CPU, right? So P3 is now going to again take the CPU, and it is going to run for next 2 milliseconds. So now let's just subtract this from here also. So time left here is 2, right? I hope it is clear. But one more point is, when P1 emptied this place, also it has to go here also. So here P1 also took this place. It should be clear that when P3 has to come here, first P1 has to leave this space, and it will go back to the ready queue and just wait for its turn. So now, as we can see that because P3 has occupied this CPU, so this is also going to be deleted from the ready queue, right? Now, who is going to come next according to this? So the next process which will enter the CPU is P2. Why? Because this is the first process in the ready queue waiting for its turn, because all these have been already deleted. All these have been deleted. So next is, so who will enter next? So P2 will enter here, and then P2 will take the CPU. Yeah. So now P2 is again going to run for next 2 milliseconds, as the time quantum is 2. So it will run for 8 plus 2, 10. Now let's just subtract it from here as well. So time left here is 3 for P2. After that, so one more thing, as I have told you, when P2 has taken this space, obviously it got deleted from here, but this has also emptied this place. So it is going to take place here in this. So here P3 has arrived. Be careful about this thing also. Whenever you are bringing some process here, you have to also take out the process from the CPU and bring back that process into the ready queue, right? So P3 has been there. Now, after that, who is there in the CPU? Who is the first process in the CPU? T1. But for that, as I have already told you now, what we have to do? First of all, we will empty this from the CPU and we will keep it here in this ready queue. So now P2 will occupy this place. So it has been deleted from here and this process will now take the place of the CPU. So now it will enter the CPU. It is P1, right? So it is no more there, right? And it is going to run for how many seconds? Next, not 10, not next 2 milliseconds, because the time left here is only 1. So it is going to run for only 1 millisecond and the time left here is now 0. So 10 plus 1 is 11. So who has completed the execution? First, P1 has completed the execution. So P1 has completed its execution. P1 is done. Now we are just left with P2 and P3. Now again here, when P1 has completed execution, who is first in this queue? P3. So now this P3 will be brought to the CPU. Now P3 will come here and P3 is going to run for how many milliseconds? Next 2 milliseconds. So 11 plus 2 is 13. Also subtracted from here also, P3 is 2 minus 2, 0. Who is the next process which completed its execution? P3. Now, so P3 has also completed its execution. P3 is also done. Who is left? Only P2 is left. Now P2 will occupy this CPU. Now P2 will come here and then P2 will take the CPU. But what is left? How much time is left? 3 milliseconds. So 3 minus 3 is 0. So P2 will run for next 3 milliseconds and it will complete its execution here. Now from this question, I hope it is very, very clear who completed its execution first. P1 completed its execution first. In case of round robin, the process which completed its execution first is P1 and then the next process is P3, right? And then the next process is P2. This is the order. Now let's go back to the question. So as we don't have to see all the options. We have to just focus on A and C because we have already eliminated B and D. They have already been eliminated. Now let's go back to the question once again. So what was the order? So P1, P2, P3 is incorrect. What is the order? P1, P3 and P2. So what is the answer of this question? The answer of this question is option C, right? So I hope you enjoyed this session and you understood the concept very well. This question seems to be very easy, but it is very tricky, right? So keep learning and happy learning. Thank you so much. Stay tuned to my lectures.